Today we're going to look at how indexing works on large tables and date stamps. So as an example, here we have a large table with 3 columns, a value, an incremental column, and a time dates column. And if I do a select star for the top 10 records, you can see that the output tells me I got a table scan, which is expected. I'm not hitting an index, and I don't even have an index. So that part makes perfect sense. So now do a typical query of select where there is a value 500, and you see again we get a table scan. So let's use another typical query which people tend to use, which is by year. So here we do a select star by year, and we get an output that again tells us we're doing a table scan. So your gut feeling at that point is probably, well, I can solve this with one index, right? And I'll just go ahead and create an index that covers both of those columns. That's my typical column usage for my returned queries. So we'll go ahead and create a non-clustered index here that covers both columns. And once that's complete, we'll do a select statement again, and we'll see the first query gets a lovely response time, and we have the index being hit. We then do a query against the second select statement, and we have a table scan. So at this point you're probably thinking, well, why is that? Well, as an example, because we included only the 2 columns. So if we do just those 2 columns and do a select statement, we can see here we hit the index. And initially your gut reaction might be, you know what, that's easy fix, right? I will just update the index to include the extra column that is part of the statement. And we run that. So we now have it includes the values of, and we run it again, and yeah, we're still getting a table scan. Yeah, okay, fine. Let's double check. So here we're definitely getting an index hit, and we're still with the original index. So let's go ahead and add the extra column value and see what happens. And go ahead and run that select statement, and nope, table scan again. So one of the reasons for this is because we're using a function. So if I go ahead and just say, you know what, let's do this query differently, and instead of using the function, I use a value, an explicit value in this case. So starting with 2023, beginning of the year, going to 2024, first possible time date stamp, so basically covering those 365 days of the year, and then run that, I will hit an index. So what's the difference here? Well, the difference is how it sees it or how it perceives it. And that's something to keep in mind. If you have multiple columns and those multiple columns switch between queries, you might want to avoid the use of functions. Now another part of you might be going, okay, well, we've rewritten the query now. Let's try without that second index because it was covered in the first one I created earlier. So let's try that. And the outcome to that is going to be, no, we hit a table scan again. So we need that second index. We need to actually index by the values. And that kind of gives you a bit of a problem. So what happens if we do it the other way around and we say, okay, well, we have the time date stamp, we have that index, and if we run the first query, table scan. So we need both indexes to cover the possible use cases here. And this is something that's very important to do, is to look at all the possible use cases you have for your indexes and whether they make sense. There is diminishing returns. The more indexes you add, the more I/O overhead with insert, delete, and update operations. But equally, without them, you have more overhead for select statements. So there is a fine balance, and it's very important to consider how you structure your tables. So as an example here, if we just recreate our index here, so we've got both of our indexes covered, there is a third option, something that can only be covered by full text index, which is something that we will not go into in the depth of this video, but just want to show you an example of how it can get even worse when you have a like statement. And when you have a like statement, you're again going back to a full table scan. So like statements can be covered by full indexes, full text indexes rather, and that's something that maybe we'll cover in another video.